Here in this video, we are going to discuss other mode of helical antenna, that is axial mode. That is axial mode of helical antenna. So as we have already discussed modes of helical antenna, there are two types. One is normal mode and the other one is axial mode. Okay. So in this video, we will discuss briefly regarding this axial mode. So what is meant by this axial mode? What is meant by this axial mode? Okay. So when you say that the antenna, the helical antenna is operating in axial. When you say that the helical antenna is operating in so here the basic condition is here the dimensions. Okay, so n into s or n into l is almost equal to the lambda. Is almost equal to means the dimensions of the helical antennas are almost equal to the one wavelength. Means for example, here let us consider. So this is here when compared to normal helical antenna, the size of the helical antenna is a little bit more. Okay, so this is helical antenna operating in axial mode whose dimension n into L or n into S is equal to lambda, and here, so this is, what is this one? This is axis of the helix, axis of helix. Okay, so in axial mode, in axial mode, the maximum radiation of the antenna in axial mode of helical antenna, the maximum radiation of an helical antenna is along the axis of the helix, along the here the maximum radiation is along the axis of the helix. So that is nothing but n pi ray. In n pi ray also, the maximum radiation of antenna is along the axis of the helix. So in axial mode, the maximum radiation, the maximum radiation is along the axis of helix. Okay. So generally, all practical helical antennas helical antennas operate in axial mode. Operate in axial mode. Here the dimensions are very more. Okay, comparable with lambda. Okay, so the condition for an antenna to a helical antenna to operate in axial mode is the mode is the circumference is selected. Circumference C is selected in order of one wavelength. In order of one wavelength. And similarly, the spacing is selected as are approximately equal to lambda by 4. So this is the very important condition you want to keep in mind while you are designing the if the helical antenna want to operate in axial mode. Helical antenna to operate in. So circumference should be almost equal to the one wavelength and spacing should be equal to lambda by 4. Okay. So these are the conditions we want to keep in mind while designing the helical antenna to operate in axial mode. Okay. So generally for an helical antenna, the pitch angle varies between pitch angle alpha varies in between 12 degrees to 18 degrees. 12 degrees to 18 degrees. And the optimum pitch angle is and the optimum pitch angle alpha is equal to 14 degrees. Okay. So terminal impedance of axial mode helical antenna is given by 140 C by lambda. The terminal impedance is given as 140 C by lambda, and the half power beamwidth and the half power beamwidth of axial mode helical antenna is given as HPBW is equal to 52 by C into root of lambda cube by n dot s. This is in degrees. Okay, and similarly, generally the beamwidth between first nulls is equal to 115 by C into root of lambda cube by n dot s. So, what is the relationship between beamwidth between first null and half? Almost beamwidth between first nulls is almost 2 times of the half power beamwidth. These are expressed in degrees. Okay. So here what is meant by the C? C is equal to pi d or 2 pi r, which is nothing but circumference. What is this S? S is spacing. S is spacing. And lambda is the wavelength. And what is this N? What is this N? The N is number of turns. Number of turns. N is number of turns. N is number of turns. Okay. So next, the maximum directive gain. The maximum directive gain of axial mode is given as equal to 15 ns c square by lambda cube. Okay, and the axial ratio for axial mode of helical antenna is generally axial ratio, it is 1 plus 1 by 2n. What is this n? Where n is number of turns. Where n is number of turns. Okay. So this is the brief description regarding axial mode. Okay. So now let us see what are the advantages of helical antennas. So it is simple construction. The helical antenna exhibits directional behavior. Okay, so this the main advantage of this antenna is it will produce circular polarization. It will produce circular polarized wave. Circular polarized wave. Okay, so coming to the disadvantage. Okay, so whenever it is operating in axial mode, the size is a little bit more. Okay, the size is so application. The main it is used in space communication. It is mainly used in space communication. So this is all the things that is related to axial mode of helical antenna.